So you ask a question, my net not work so good, so you kind of break up.
No, that other person's heard. The question was, the question was, what must be different between two objects for heat to flow between them?
Where I say temperature, I don't know. Just
That's a
again.
simple one-word answer.
Oh,
Simple one-word answer. Must the temperature. We do that last class, no? We do that last class. That sometimes I question whether people learning online, especially when camera turn off and then probably leave the computer or whatever device they using and go about in business. Man, see it here. It's right here. It right here. It was one of the answers for the question in the lab. Heat will always flow from a higher temperature object, a hotter object to a colder object until both objects reach the same temperature. And here I am today asking the question, what must be different between two objects for heat to flow between them? And everybody playing dumb, you know, like something, cut off your tongue or something. So I don't know. But that was the question. So yeah, that was the answer actually. Temperature is the temperature has to be different between two objects for heat to flow between them. Um so in other words then, all right, let's ask another question then. So you're at home and you're feeling a bit thirsty. You go to the fridge to open it and to take out maybe to take out a drink or something. In from which direction would the heat flow from when you open the fridge? Where would the heat flow from?
outside, or because the fridge inside are cold, so I just say outside.
From outside the fridge. Mm, hope everybody is listening. But if you're not answering, nobody going to answer, which is very shocking. A month before the exam. All right. Well, the evidence is there, so I did my part. So you must know what you want for yourself. All right. Anyway, so that's what's the answer. You guys need for sure so I learn something. So I don't know what it will take. If I send past papers, the same persons do them all the time. And then the persons who I would want to see do them not doing them. I don't know if it's shyness or you know or whatever it is. But people don't learn as you can't know by not participating, You need to speak. Um, that's what it is. If you got to like 3 years old and your parents never hear you say anything, what do you think will be going through their minds? Not even a
You have a,
sound.
you have a disability, sir, or something like that.
Exactly. The same thing with the teacher now. Teacher, they will attack you for how much months, and we are trying to make you grow in a knowledge, and then we reach what? Don't know, it's almost exam time, and so go and left me know, and then some person not saying anything. It's the same thing because you came into the class being able to talk. Right? I know that the last time I checked, I wasn't told that anybody was hearing impaired or speech impaired. Or that nobody, or there somebody in the class that didn't have a tongue or it was cut off or something. I never got that information, so I'm expecting that persons are able to talk. I'm not expecting everybody to be an Einstein or brilliant or, but mean, the floor is open for everybody to talk. And some persons grab the opportunity while others just, don't bother. And what's gonna happen? Well, if there should be a famine and food start dash out, the person who want the food most will survive. The body will stay at the back of the line. Well, I guess you get to the duck get them say. Anyway, word to the wise. So let's get on with it. All right. So reason I ask that question, this thing has to do, and this lab number 7 has to do with, and let's look at the problem statement. All right. And I'm going to put today's date on it. In fact, today is the 29th. And there you have it. All right. Of course, the skill is plan and design, as stated before. All right. And what we have here is a situation. And it's that Dwayne believes that dark colored objects will absorb more heat than light colored objects, and causing them to feel hotter when exposed to sunlight. And plan a design an experiment to determine if dark or black surfaces are better absorbers or emitters of radiation. So we're underlining the key terms here: absorbers and emitters. All right. So that's what we're gonna I'll speak to this very quickly today. All right. So now the question is now, do you believe, class, that dark objects attract more heat than light colored objects?
Yes, sir.
Yes, sir.
Yes,
All
sir.
right. So Amari and Janari saying yes. I heard a female voice saying yes. Was it you, Giovanni? Ashanti? Okay. All right. Yes. All right. So you say yes, and you say it very confidently. So Amari, tell me your experience with dark objects, like a dark clothes or something. You have any experience with what's your experience with dark objects?
So sometimes, like, if I put a chair outside, sir, and I touch it, sir, and I come back and like try to sit on the chair, like, sir, it burn me sometimes, sir.
Okay, stick up in there. So a chair outside.
Yes, sir.
Good. And when you say outside, I suppose you mean exposed to the sun. All right. What color chair?
Like a black leather chair, sir.
Oh, black leather chair, say. Okay. Leather chair. Interesting. Have you ever tried that with a white chair?
Yes,
Anything?
sir.
All right. And you say that the black chair felt hot. What about the white chair outside in the sun?
Not really, sir, even though it's plastic.
Yeah, that's a good way to observe it. Definitely a good way to observe it. All right. So yeah, let me just change the screen. I don't know what happened here a while ago. I want to change the screen. Yeah, so all right, very, very good observation there, Mari. Janari, you were saying something? Anything like that happened to you?
Sir, pot.
Pot.
Like one black pot, then black pot, they absorb heat quick.
Compared to what?
Yes, sir.
Compared to what other kind of pot? Because yeah.
The shiny pot them, sir.
Oh, okay. Okay, fine. Accepted. Anybody have any experience like that? Or other experience?
But sir, something weird though, sir. Like then sometimes make this kind of look a black top, sir. So I touch it in the hot, sir, but you say pot we hot, sir. We understand.
Hold on to that.
Like one black angle, sir. If you touch it, my top there, so the pot cover, sir.
Yeah.
It is not going to be hot, sir. Like it don't absorb no heat at all.
Yeah, we
will
absorb. We will definitely come to that later on. But very good point though, Janari. I heard Benito and Shanta are trying to say something. So
Sir,
Benito, yes, Benito.
we wear a black shirt with you.
Mm-hmm.
I have on a black shirt and I saw him a bono. And
Mm-hmm.
then we took off the black shirt and put on one white one.
Mm.
You know, if you know, hot like when me have on a black shirt.
Oh, okay. So that's a feeling. Yeah, that's good. Good point there, Benito. So clothes, it happens with clothes. Generally saying it happens with pots, and then Amari saying it happens with cheer. Anybody else have the experience? Shanta,
Sir.
you were saying something?
Sir, it's similar to what Benito said, sir. Sir,
Mm.
I play sports, sir, and like whenever I'm training or anything, sir, in the black shirt, sir, I feel hotter, sir, and like I sweat more, sir. But as soon as I change the shirt, sir, I
Mm.
sweat less, sir.
Okay. All right. Good point. So you say you play sports. Interesting. As Bishop, we were playing sports. That's rare. Which sport is that?
Sir, badminton.
Okay. Yeah, definitely. One of those sports. Yeah. I love that sport actually, but I don't play it a lot. No, don't have the time. But it's a lovely sport though. But yeah. All right, badminton. Yeah.
Sir, and that's why Fus can agree with his son too, sir.
Yeah, all right, Jen, all right. You're going into some argument if you don't want to go there, say it, you know.
Sir, if any ultraviolet is from his son, sir.
Yes, Jen, all right. That might be true. But we don't want to start a debate about melanin, dark skin, and them things. We want to focus on what this lab is trying to say. No, all right, I want you to look at the screen now. All right, everybody seeing this graph on the screen?
Yes, sir.
All right. What you're seeing here, what are you seeing though? What do you understand from what is on the screen? All right. Obviously, you're seeing a graph, right?
Yes, sir.
Right. So it's a graph, you know, with bars here. All right. Bars are telling you the surface temperature of different materials used to make roof. All right.
Yes, it's well said, sir. A Zoom call kind of just went mute. Like internet connection and still we just went mute.
Oh, sorry about that. Anyway, but the point is here, different materials can be made, can be used to make roofing. All right. And if you look at this, the names are given. So we have, for example, the first one towards the left, ambient air temperature is 95. And this probably is Fahrenheit. Not expecting this to be Celsius, really, 95 degrees Fahrenheit. Or is it though? So confirm that 95 degrees Fahrenheit, 95 degrees Celsius. That's almost, that could boil water. Air temperature not likely to be 95 degrees Celsius. It's actually gonna be 95 Fahrenheit, guys. So all right, 95 Fahrenheit, which would make this American sort of graph here. All right, so everybody seeing the first one here, ambient air temperature. Let's see if we can get a zoom, so it will get clearer. All right, ambient air temperature. So that is the temperature of the air around, guys. 95 degrees. This looks to be maybe the temperature in California there and the West Coast there. But ambient air temperature at 95. But then these roof, white acrylic coating, white cap sheet, these are all materials that are used to make roofing. And we have 115 degrees for the white acrylic. But then look at the black. This looks to be single ply, black single ply here. That's the last one, right? The black single ply is what? 193 degrees Fahrenheit. That's hot, guys. Your body temperature should be 98. Yeah, I think it's 98 degrees. In fact, if you had any of these temperatures on your skin, then they will say you have COVID. You know, your temperature should be in the 98 region. All right. But 115 for the white roofing, and then for the black single ply is 193. What would cause that? if you can answer that question, then this lab is virtually easy for you guys. Right? What causes the black single ply to be 193 and the white acrylic coating to have 115? White at 115,
So
black
then
at
say,
193. Yeah, go ahead, Janari.
so I'm just say why then say so
All right. You know, this black object thing, you know, you see, black is a misunderstood word in our society, you know, guys. When you hear the word black, everybody is thinking of a shade. And I want to tell you that in physics, when we use black, a lot of times it's not referring to any shade or the opposite of white. Black is actually it's just funny though, named after I don't know if you ever heard this name before. That name. All right. Black is named after Joseph Black. All right. Why we use the word black? In the so in the times when probably a lot of your forefathers were leaving the African West Coast to come here as slaves against the will. They weren't called black people then. They were called other things, but not black.
so just like a white man never call white man, they usually call him pale skin, sir.
If you want to put it that way. So yeah, so black, the point I'm trying to get to is that black is a behavior. Okay, black is not a color or a shade, it is a behavior. All right, what type of behavior it is? All right, according to Joseph Black, what he said, a black a black body, as the term he used, is an object that absorbs and emits all forms of radiation. Okay, so that is his definition. And so the term black body in physics refers to any object that can absorb all forms of radiation, which we're learning today that radiation is one of the ways heat is transferred. All right. Anybody remember the 3 ways in which heat is transferred?
Sir, conduction, convection, and radiation.
Wait, Shante, why are you looking good today, man? That's good. Yeah, that's actually true. So, so heat. All right. So, and let me just add to this sentence: black bodies absorb and emit. Not just absorb, but any object that absorb radiation will also emit it. So black bodies absorb and emit radiation. Well, in fact, all forms of radiation. So I will say all forms, it could be, you know, let's see, it could be even radioactive type, you know, gamma rays and X-rays. And so maybe if you go to do an X-ray, you might be in a little bit more danger when you wear a dark colored you know, fabric. So you might want to, next time you have any tests like that to do, you might want to wear something like that. But black bodies absorb and emit all forms of radiation. All right. And that's heat. Radiation is heat in the form of waves. All right. So radiation is heat. All right. So therefore, heat is transferred. Heat is transferred via these 3 methods. And as Shantai mentioned, it's conduction, convection, and radiation. All right, so yeah, heat is transferred by those 3 methods. All right. Anybody have any questions?
No, sir.
Okay.
No, sir.
So we are doing this lab 7 here because of Joseph Black. Joseph Black was maybe I think he was an 18th century European physicist. All right. Let me just see if I can find him.
Sir, I think a Scottish, if you mind not fool me.
He's Scottish.
Mhm.
Okay, well, Scotland would be a part, would be a part of UK. So yeah, probably most likely Scottish. That's true. Let me just confirm that though. And it definitely is Scottish. Yeah, definitely that's true. So certainly from the west coast of Europe, west side of Europe. And but they said he was born in France. Okay. You end up there. All right. Yeah, this guy discovered specific heat as well. So that's Joseph Black. All right. So thanks to him, we have this to do. And if he learned this in his time, he actually died in 1799, 18th century guy there, so 1799. It's a long time ago. All right. So anyway, point is that you guys going to plan and design an experiment. Just picking one of these hypotheses here and plan how you're going to test it. All right. Black material will absorb more heat from the sun than a white material. Just pick one or choose your own. Well, write your own, I should say. You could write one. But make it something that is easy to carry out. But these are examples of hypotheses that you would use for this one. All right. And also before we actually end here, I think I have a sample of I think I had a sample of one that was done. So, I could probably send that in the group for you to expedite the writing up of this lab. Let me just find that one. But certainly lab 8 definitely is a crucial one there. All right. So it is. I think this is it. Yeah, I'll show you a sample of one that was done. Anybody seen this?
Yes.
All right. So yeah, so this particular one was done by a student really that kind of brainstormed it together and said, well, all right, this one. But this person actually planned to use clothes on the line to carry their own out. And so they chose number 1 and carry this out. Determine if dark colored fabric absorb more heat from the sun than white fabric. So you want to use different colors here. And of course, you need something to measure temperature. Maybe a clothesline and some pins. And you're carrying out this experiment. So the idea here is that the student would have just well, let's see what they want to do here. Obtain 5 colors of clothing of the same type. Submerge the clothing in water. Remove clothing from water. Place them on the clothing line using pins. Check the color of each clothing every 10 minutes. Record the observations in a table. Simple. Variables here. White fabric. Control variable would be the white because, well, you want to use white. Just like how I showed you the graph with the roofing, and white had to be in there because you're comparing every other thing to the white one. So the control one will be the white, and of course the sun and the time that you use to check the dryness. Those are control. But the independent variable is the colors that you're using. So again, using like these colors that you see in the diagram. We're seeing some red and some yellow, blue, and green there, but those are the manipulated variables. And then the responding variable will be the dryness of the fabric after 10 minutes. So you check them 10 minutes. You want to see if them dry. All right, any questions here, guys?
No, sir.
All right, That'll be simple here. Of course, you have a relevant theory here.
Sir,
All right, yes, go ahead, Benito.
sir, me do that opinion there, but me use towel. I see him
Towel.
things.
Yeah, you use towel. Okay, cool. Yeah, so how that lab they reach at Chester? No. All right, well, so I go again. All right, relevant theory. All objects give out and take in thermal radiation, which is also called infrared radiation. The hotter an object is the more infrared radiation it emits. All right, so this is information that you'd need, or that would be helpful to this. All right, comparison of surfaces' abilities to reflect and absorb radiation. No, it has to do with the color, the type of finish, and then we describe it as poor. Or this has actually come in a CXC past paper. Actually, it came in 2007 or 8, and it came again in I think it was 2016, if memory serves me correctly. So this is very likely, could be, especially if it's a past question, it's likely. You might get it this year. All right, so color, dark or light, and then of course the finish, dull or matte black. Of course the dull surface, dark and dull. Can you think of anything that's dark and dull? No, dark and dull. All right. Well, at the same thing. Well, if we have something similar to what General was talking about, the part handle, part cover. Usually make from something like Teflon or something like that. Anyway, whatever it is, it's a hard plastic that it's dull colored. And then dull finish rather. All right, matte. Matte is like what? Matte black. I mean, like some really black surface. Maybe some car. So yeah, some black car color, black car type of thing. All right. Point is that if you color dark, the ability to emit radiation is good. Ability to absorb it is good. If it's light and shiny, then it will be poor. So in other words, if you don't want radiation to be absorbed by an object, you just make it a light color and you make it shiny. All right. So all right, so that's the situation there, guys. All right, so that's it. So you're going to use that knowledge to plan, and then this is how we went on to plan it. We have a color, black, white, or any other color you're using, and you're recording the observations every 10 minutes until everything dry. And of course, your expected results, the darker colored fabric is expected to dry first. Well, yeah, there you go. And so expected results there. All right, so this is an example of how the lab, is supposed to be written up. That will take care of lab 7. All right, so any questions here, guys?
Oh, sir.
All right. Well, that takes care of that. 8 minutes past 8. Let me see. So that's a sample of the lab. Okay, so we're going so we're just going to keep it short tonight. As it relates to lab 8, we have to go all right, yeah. If you have lab 8, there are some videos that are actually in it. So you're going to have to go watch those videos. And let's see some. So I think I saw the Chanel, but she gone. All right. Yeah. So the lab 8 now, guys, have information in it that some videos links that you probably you need to watch them to understand the lab. So just follow that. All right. So if you have any questions, just ask in the group about lab 8. So that should take care of all labs. And those labs now, I need them for next week. All right. Next week, Tuesday. All right. So possibly we might meet, or we might, well, I'll try to meet on Saturday. I'm not sure Saturday anyway. But if it work out, then we meet to discuss those labs. All right, guys. So if you don't have any more questions, so we're going to just we're going to send you off to bed. And thank you guys for coming out and and stay safe. All right.
Yes, sir. Merci.
All
Merci.
right.
2 more labs, sir.
2 more.
Yes, sir. I'll just keep on.
All right.
Yes, sir.
All right. Then. Cool.